we are going to start off by looking at section 2.1. So 2.1 is on zeros of polynomial functions. So we'll talk about what are polynomials, and also what does it mean to have a zero. Well, let's look at this graph. Okay, this is an example of a polynomial. Specifically, that is a cubic polynomial, or you could also say it's a degree 3. Okay, so we're going to learn all these different terms to describe that. But let's graph it, and the focus is going to be how many times it crosses the x-axis. Okay, that's what I want to focus on. Okay, we might look at some other things like see how many times it crosses and how that's connected to how many twists and turns are in the graph. Let's take a look. So we've got 2x cubed minus 3x squared minus 3x plus 2. And what's the window that we always use when we're starting to look at the picture is kind of our go-to point just to start out. What's our window? Dario, do you remember that? What's our window we use?
Zoom stick.
Yeah, Zoom. And what did you call it again?
6.
Yeah, Zoom 6. That's just our standard window. So let's type it in, see how it looks. Okay, that's a very good window for that graph. Okay, looks fine. So let's look at first, how many times does it cross the x-axis? Yep.
3 times.
3 times. Yep. And notice that's a 3. Okay. That highest number doesn't always guarantee it's going to cross 3 times, but that number is a maximum number of times that it could cross. Okay. I could have made it so this graph crossed twice or once. It would be impossible to get none. Okay. You always have to have 1 in this type of graph, and we're going to learn more about why. So this particular graph crosses 3 times. 1, 2, 3. And now, when we're looking at all of those points, all 3 of them, what is the y value of a coordinate that's on the x-axis? Well, Gregory, what's the y value of a point on the x-axis?
0.
0, yes. So the y value for any coordinate where the graph crosses the x-axis is always 0. That's why when we talk about an x-intercept, we a lot of times refer to it as a 0. Okay? So I want to show that this graph right here, x plus 1 times 2x minus 1 times x minus 2, is exactly the same as this. How could I show that those 2 things are exactly the same? Lens, how could I show that they are the same?
Would you plug in a 0 on both of the equations?
But in general, plugging in a number doesn't prove they're the same unless you're capable of plugging in every single possible number you ever could and then showing me that every single answer comes out the same. But there's a lot of numbers you'd have to plug in to do that. There's an infinite amount of numbers. So we can't plug numbers in to show that they're the same. That's a good guess. Anyone else have a thought of how we can show they're the same? Yeah?
Distribute and then factor.
Yeah, just distribute it all out. Okay? Let's just multiply all this out and see if we get what's in the red box up above. If we do, then they're the same. So let's multiply this out. Okay, so let's start with just doing the first 2, and then we'll worry about the x minus 2 after. So let's do the first one. What's x times 2x? That gives me how much? Yep,
Would it be 2x squared?
2x squared. X times -1 gives me, how about Travis?
Negative x.
Yep, and I'm just going to put that off to the side for a second because I'm going to combine like terms before I write it down. So we got -x and 2x times 1. Ethan?
Just 2x.
Just 2x. And what's -x plus 2x? Jackson.
X.
X. So let's combine those. And 1 times -1 is -1. Okay, so we've multiplied the first two together. Now we have to multiply that times x minus 2. So let's distribute one more time. Okay. Marin, how about 2x squared times x?
It's just 2x squared.
If you multiplied by 1, it would be 2x squared, but we're multiplying 2x squared by x, so it's going to change it.
3x squared.
No, not 3x squared. Anyone help her out? What's that? Yep.
2x cubed.
2x cubed. Okay, so when you are multiplying variables, those exponents get added up. So x squared has a 2, x has a 1. Multiply them, it's 2x cubed. How about, let's do this. X times x, that gives me how much, Emma?
X squared.
That's x squared. And we got one more to do with the x. X times -1 is -x. Now, the last thing is distribute the -2. Okay. What's 2x squared times -2? Evan.
-4x squared.
Yep, -4x squared. -2 times x is -2x. -2 times -1 is +2. Okay, let's combine our like terms, and now we're going to find out, is that what I wrote down the same as what we had up above? 2x cubed. We have x squared minus 4x squared. That's minus 3x squared. -x, -2x gives us -3x. And the only thing left is a +2. So let's compare what's in that black box to what we had in the red box. How do they compare? About Raj.
It's the same thing.
It's the same thing. But what were you going to say?
It's just like, that's why the 3x squared is on the other side.
So they're the same thing, but what? I'm not sure.
Never mind.
Oh, okay. Yeah, they're exactly the same. Yeah, exactly the same thing. But there's a real advantage to knowing how to write it that way. Okay, really big advantage. So let's use the calculator and see if we can figure out where the graph crosses the x-axis. Okay. Yeah. Okay, let's do one on the calculator, and then we're going to come back to what we have written right here and see if you can figure out how to use that, which again, this is the factored version, how that helps you. All right, so let's go on the calculator. And you're going to press second calc, and we're going to calculate where it crosses the x-axis. Okay, that is called a 0. Right, so on my calculators, you'll see the option 0. Another word you might see is root. Calculating a 0, calculating a root, it's exactly the same thing. But my calculators say 0. So we're going to go to option 2. And now, it can only give us one at a time. There are 3 of them. Okay, so what we're going to do, it's going to ask us 3 questions. First question it says is left bound. Okay, I'm going to do the one that's all the way on the left side of the screen, right here. So I need to put my cursor somewhere that is to the left of where it crosses the x-axis. And that's fine right there. When I hit enter, it creates kind of a boundary line on the left that says, okay, I'm going to look between that line, and now I need to move my cursor somewhere to the right. I don't want to go too far to the right that I get these other ones in there. I just want to go far enough to make sure when I hit enter that now I've got these boundary lines that are putting kind of almost like a little column that the calculator is going to look in for where it crosses. Okay. And now the last thing is the guess, which doesn't really matter because the way I set up my boundary lines to make sure there's only one answer that it's going to find. So hit enter one more time, and look what it says for the first 0, -1. So that means if you plug -1 into this original formula for x, you will get 0 for y. -1, 0 is one of the x-intercepts. So that's one of them. Okay, let's see if we can find the other ones. Now, without using the calculator, can anybody look at this and see if they can tell me where those other zeros are going to come from? There's 2 more. Yep, Marcelo?
Whatever in the parentheses, if you make that equal 0, the whole thing's going to be 0.
Yes. So could you tell me for that middle one what you could plug in for x to make that one 0?
A 1/2.
Yep, that would be a 1/2. And how about that last one?
2.
2. Yep, exactly. So if we had done second calc 0 2 more times, you would have gotten 1/2 and you would have gotten 2. So the advantage of writing something factored is it makes it very easy to find the x-intercepts. Okay. If it's not factored and it's all done out like this, that's a lot harder. How could you tell looking at this that you could plug in a 1/2 and it would all come out to 0? You can't, right? But factored you can. So by the end of us working with polynomials, you are going to know how to take something like this and turn it into something that is factored. Okay? You should already be able to factor a quadratic, but maybe not things that are higher than quadratic. Okay. All right. Any questions on that one? All right. So you're going to see me or you're going to hear me say the same thing lots of different ways when we talk about polynomials. I might say that a number is a 0. I might say it's a root. I might say that that number is an x-intercept. They all kind of mean the same thing. So let's kind of just summarize that. So if I'm telling you that a number you could plug in, which I'm going to call a, is a solution to the equation when you set it equal to 0. Setting something equal to 0 means you're solving for the roots. Okay? And that's exactly what I did. Right here. Okay? We set that equation equal to 0. Right? In other words, it's like we graph the line y equals 0, which is the x-axis, and we found where it crossed. Now, I could have actually done it that way. I could have put in the line y equals 0 like this. Okay. So now I just graph that equation, and to figure out where y equals 0 hits my curve, I could do an intersect. Okay. Now that I have the red line there, could do that, could do that, and do that. And it gives me the same answer. The way I did it with you is instead of having to draw this second line, I was able to calculate where it crossed the axis using second calc option 2. Okay, so option 2 is a way to figure out where it crosses the x-axis without actually having to draw a line on the x-axis. Okay, so if you find a number that you can plug into an equation, and that, when you plug that number in, it gives you an answer of 0. That number that you found is called a root. It's also called a 0. If you write that number as a coordinate, like -1, 0, that's the location of the x-intercept. Now, that equation was a little more complicated. That was a cubic polynomial. The highest exponent is the number of times, is the maximum number of times the graph could cross the x-axis. It's not a guarantee that it will cross that many times. Okay, for example, if I type in x cubed, highest exponent is a 3. But when I hit graph, how many times does the red one cross the x-axis? We can zoom in a little bit so it looks a little easier to see. But how many times does it look like the red graph crosses the x-axis? That one's 3. But now look at the red one.
Looks like once.
Yeah, it is just once, and it is just right at the origin. So even though the highest exponent is a 3, it is only crossing 1 time. Okay. So cubics can have 3 different scenarios. There's a cubic that crosses 3 times. There's a cubic that crosses twice, or we'll say touches the x-axis twice. And here's a cubic that only crosses it 1 time. And the way I drew that curve, they can kind of be going up, down, and up, or the cubic can also curve the other way, down, up, down. You can have that behavior as well. Now, it can never be 0, right? It can never cross 0 times because this type of graph goes up forever and it goes down forever, and it's connected the entire time. So think about if you go up forever and down forever, and you're always connected, are you going to cross through 0 at some point? Yeah, you have to. It's not like a parabola. Parabola is different. Parabola doesn't have to cross the x-axis. It could look something like that. But this one always will. All right, let's think about a line. If you have a line, just sign back in. If you have a line that's not horizontal, horizontal could be a special case. Any other line. What? How many times can a line cross the x-axis? At most. Yeah.
It would be like once.
Right. A horizontal line can only cross the x-axis at most 1 time. Now, if it was horizontal, I guess if it was a horizontal line right on the x-axis, that's different. But any other line can only cross 1 time. Now, this is the equation of a horizontal of a line. It's like mx plus b. I used a different letter. Where would this graph cross the x-axis? I'm looking for a formula if you get x by itself. Yeah?
0b.
Well, the b is the y-intercept. But yeah, we're looking for that x-intercept. What would be the, you don't have to give it to me as a coordinate, what would be the expression for the root in that one. Yep.
Negative b divided by a.
Yes, negative b divided by a. So that's kind of like the quadratic formula, but it's a lot simpler for a line. Negative b over a. So if you set a linear equation equal to 0, the root is negative b over a. If you set a quadratic equation equal to 0, then the formula gets a lot more complicated. You get the negative b plus or minus the square root of b squared minus 4ac all over 2a. So it gets a lot more complicated just for a quadratic. All right, but that's the formula if you set a linear equation equal to 0. It's negative b over a. Okay, so now let's see if we can just find the root in this equation. Anybody tell me what the root is for 2x plus 3 equals 0? Yeah?
Negative 3 halves.
Negative 3 halves. That is the root. What is the 0 of that equation? What's the 0 of that equation? Buff traps?
The same thing.
Yep, it's the same thing. What's the x-intercept of that equation? Remember, x-intercept, the answer to the format is a little different. But what's the x-intercept here? Oh, yeah, Nick?
Negative 3 halves 0.
Negative 3 halves, comma 0. X-intercept is a location. It's a coordinate. Yep. So that number tells you all three of those things. Tells you the root, tells you the 0, tells you the x-intercept. Yep. All right. So now, there's not really a lot more to say about linear. Let's step it up to quadratics. Okay. How many zeros can a quadratic have? And remember, we're just talking about real. We're not considering imaginary. Thinking of how many real zeros it could have. Oh, yeah, Lance?
Would it be like 2 or more?
No, it wouldn't be 2 or more. You couldn't have 2 or more zeros in a quadratic. Well, Jake, any thoughts?
Would it be just one?
That's one possibility. You could have one root. What else? Yep.
0 and 2.
0 and 2. What would it look like if you had one root or 1 0 in a quadratic? How about Annalise? What would that look like if you had a quadratic with 1 0? Well, what's another name for a 0 is a what? A root. And what's another thing we've talked about with it as well? X-intercept. So what would it look like if a quadratic only had one x-intercept? I'm thinking, like, I want to draw it right now. So not exactly like an equation that would have one intercept, but the actual picture. Sure, Lens?
No. Would it be like?
I wasn't sure if that was a hand up or not. Yeah.
No, just like imagining it. I think it would be like, it would sort of be upwards, and then after the x-intercept would be like sort of wavy.
Well, it's a parabola, right? So we know a parabola has to have what shape to it? Yeah?
I was just going to say the vertex has to be on 0. Or on the x-axis.
Right, the vertex has to be on the x-axis. That's the only way you can have a quadratic that would have one root. Okay, you could have a parabola, like that, or you could have one over here, or you could put one right there. But if a quadratic is only going to have one root, it needs to only be touching the x-axis in one spot. Okay, two roots, well, just have the vertex be somewhere not on the x-axis, and have the parabola opening in a direction where it crosses it. There you go. So there's a parabola or a quadratic that has two, and then none. Well, shift the parabola. If you shift the parabola up and have it open up, it would never cross. Or if you shift it down and have it open down, it would never cross. Yes?
Can I go to the bathroom?
Yeah. Okay, so the answer here is 0, 1, or 2. Now, we have a quick way to figure out how many times it crosses. Does anybody remember if you do this calculation, there's 3 different results that can happen. And does anybody remember how b squared minus 4ac tells you which one of those 3 cases you have? Talked about this at the very end of the lesson. I think it's when we were completing the square, that lesson. Yeah?
If it's like if the answer is less than 0.
If it's less than 0, yeah?
It's zeros.
Right, if it's less than 0, you've got the situation that looks like that. So that's one possibility. B squared minus 4ac is less than 0.
It's equal to it, and it's 1 0.
If it's equal to 0, then what happens there?
So it's 1 0.
It's 1 0. So you've got a situation that looks like that.
If it's greater, it's 2 zeros.
If it's greater than what?
It's 2 zeros.
Well, but greater than
0.
greater than 0. If the result comes out positive, then you've got 2 zeros. So those are the 3 cases. B squared minus 4ac comes out less than 0, equal to 0, or greater than 0. Right, so that's a quick way that we can tell how many roots our graph has. Okay, so let's try this one. The directions say to solve approximately. That means we do not need to write the exact answer. With a quadratic, exact answers, if they're not factorable, require quadratic formula or completing the square. Using the graphing calculator on a problem that doesn't factor will always give you a decimal. Okay, so we don't, if it said exact answer, we probably want to be looking at factoring a quadratic formula. But approximate, we can use the graphing calculator. Okay, what's our first step to solving this quadratic? Daria?
Subtract 1. Wait.
Well, what's the goal? Anytime you're solving a quadratic, you want to start out by having it in a certain format, and that's not it. So you don't even have to tell me the steps to get it in this format. I just want to know what is the goal when we're setting this up to get ready to solve it. Yep.
You said equal to 0.
You want it equal to 0. So you want it equal to 0, and I would recommend the x squared term being positive, because if you're going to factor, that's how you would probably talk to factor, with the x squared term positive. So can someone rewrite that for me with the x squared term positive and get it equal to 0? Yeah.
2x squared plus 2x minus 1. Minus 1.
Yep, minus 1
Equals 0.
equals 0. Perfect. So 2x squared plus 2x minus 1 equals 0. Now, we could try to factor that, but again, it is not factorable. So we've done quadratic formula before. I think we did that maybe with like a rectangle problem. something. I know we used it last week. So let's practice doing it on the calculator. Okay, so we're going to type that equation into y1. If you've got anything else, just clear it out. 2x squared plus 2x minus 1. We'll do zoom 6. And based on our graph, it looks like we are going to get 2 answers. Okay. Let's start with the one on the left. Can somebody tell me? And I don't want to graph another line. So yes, I could put in another line at y equals 0 and then do an intersect. But I don't want to do an intersect. Or I'd like to do it the way I just showed you. So how do we find where it crosses those 2 times? And I'm just going to zoom in so it's easier for you guys to see. How do we get, let's do the one on the left. Yeah.
Second calc.
Yep, so we're going to do second calc.
0.
Yep, we're going to calculate a 0. All right, now it's going to ask me 3 questions. What do I have to do? I got to hit enter, but I got to make sure everything is set up right. What do I have to do with my cursor for the first step? Yep.
Move it to the left side.
Yeah, we got to move it somewhere to the left of the 0. Hit enter. Okay, how about my second question? What do I do with my cursor now? Yeah.
Move it to the right.
We're going to move it to the right. And after we move it to the right, then,
Click enter.
yep, hit enter. And the guess, because of the way we just set up those boundaries, the guess doesn't matter. And we get negative 1.37. And a decimal is okay because they said approximate. Right? If they said exact and you tell me negative 1.37, it's wrong. It's not. That's not exact. Okay? Even if you write down all these decimals, it's not exact. The exact answer is something like a number plus or minus square root something over something. That's the exact answer. Okay? And you need quadratic formula. Okay, so negative 1.37. And did anybody get the one on the right? It looks like it's probably 0.3 something. Yep.
0.3660.
So 0.366, so 0.37 if I round.
Yeah.
Okay, thank you. There you go. Those are the 2 roots. Those are the 2 zeros of that quadratic approximately. Okay. Any question how to do it if I asked you for the exact answer using quadratic formula? Yeah.
Could you
Do it with the quadratic?
Yeah.
Yeah. So you got A, B, and C. So negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. Minus a minus becomes a plus. So that's negative 2 plus or minus. That's going to be 4 times 2 is 8. 8 plus 4 is 12. And if we reduce that as much as we can, square root of 12 is, you can break 12 up into 4 times 3. So it's 2 root 3 over 4. And once I reduce that, all of these numbers are divisible by 2. So if I asked you for the fully simplified answer, I'm looking for negative 1 plus or minus root 3 divided by 2. Now we can check that against the decimal and make sure it comes out to negative 1.37. So I'm not going to check both, but I'll check one of them. So negative 1 plus the square root of 3, and then divide by 2, and I get 0.366025. That's the second one. Yep. And then if I did negative 1 minus root 3 over 2, That's the negative 1.37. Okay, so these are approximate. These are exact. Exact was not part of the question here, but someone asked me to do it, that's why I did it. All right. Any question on that one? Okay, so let's talk about how we can find roots graphically. Now, this, I wouldn't worry about writing this down. This is on like if you have an older calculator and it doesn't have second calc 0, okay, this is how you would have to find the root. Okay, let's go back to graph. And what I would do is do zoom 2. Right? Zoom 2 just zooms in. And I'm going to zoom in on this one. What I can do is I can press trace. So now I'm on the curve. And I'm going to watch when my y value goes from negative to positive. When this value goes from negative to positive, then I know I've crossed the x-axis. Okay, I'm at negative 0.21, 0.01. Okay, I just went positive. So what that tells me is this root is somewhere between 0.3598 and 0.369. Right? It's somewhere between those two. If I wanted to get an answer to 2 decimal places, well, I have it right now. If you round that, it's 0.36. And if you round that, actually that's 0.37. So if I wanted to get an answer to 2 decimal places, I'd have to zoom in again. So I go zoom 2, hit enter. Now I'm zoomed in even more. And see if I can trace again and watch my cursor. Okay, there I'm at negative 0.005, and the answer is 0.36. Now I'm at positive, and the answer is 0.3669. So it's getting closer. That's how you have to do it if you don't have second calc. You got to keep zooming in until you get as accurate of an answer as you want. So it's getting close. 0.367, 0.365. Okay, I'm only 2 thousandths away from each other, okay, when I zoom in now. But that's going to take a while to do it that way. And if you've got 3 or 4 of them to do, well, now it's going to take even longer. So the best way to calculate the roots is to use the root or the 0 feature on the calculator. And that's what we use. Okay. But if you have a TI-82, that's an older calculator, some of the TI-82s, I believe, don't have that calculate menu. It's either the 82 or the 81. You're not going to find many of those calculators. In fact, brand new, I don't think you can even buy that. Anyone that you can get now that's a TI, it's going to have the calculate menu. All right, so let's try this one. This is one that might be a little bit harder to do algebraically because I haven't taught you how to factor a cubic yet. Okay? The only way that you're going to solve that algebraically is if you can factor it. If it's not factorable, then we're going to have a hard time. Why can't we just use quadratic formula on this? Why am I saying we'd have a hard time with it? We have quadratic formula, we could just use that.
It's cubic.
It's a cubic, it's not a quadratic. Okay. Is there a cubic formula? Yes. So you saw how much more complicated the answer gets when you go from linear. The answer is negative b over a. And then you go to quadratic, it's negative b squared. Now you got all this. Well, there is a formula for the next step up, which is the cubic formula. It's not a formula that we learn. It's not even one that I know off the top of my head. But it's very long, very, very, very long. Okay, it might be like a page long. So there's a formula to do it, but it's pretty complex. And then I think there is a formula for one step beyond that. That's the quartic formula. That one's extremely long, but that's the last formula that I think they have. There's nothing, I don't believe there's anything when this exponent is a 5 or higher that you can just plug it into a formula and get the answer. Now, in reality, it doesn't matter how long the formula is because you can always build a computer to just, calculate it out. It's just a matter of, is there a formula? Does it exist? Right? That's the question. So right now, we don't know the cubic formula, so we're going to graph it, and we're going to do it approximate. At most, does anybody remember how many times I said this could cross the x-axis? Yeah?
3 times.
It could cross 3 times. Now, when we solved the last problem, look at how we got it set up. When we solved the one before that, look at how it was set up. Now, let's look at this one. What do you think I'm going to want to do to this equation first before I type it into the calculator? So it's set up similar to the last 2 problems. Yeah, Raj?
Subtract one of those sides.
Yeah, why? What are you trying to do?
Set the other side is 0.
Yeah, let's get it equal to 0. So this is x cubed plus 2x minus 1 equals 0. That's what I'm going to plug in on the calculator. As long as we get it equal to 0, then we can use the 0 feature on the calculator. If it's not equal to 0, you cannot do that. So we got x cubed plus 2x minus 1. Okay, we'll start with zoom 6 and see how that looks. Okay, so what do we think? Is that a good window for this graph? Lens?
I think it is.
Yeah, it's a good window. That's fine. This particular cubic doesn't have the behavior where it reverses direction. Okay. The slope in this cubic is always positive, meaning it's always going up. Right? It never does something like that, where the slope actually levels off at one point or even becomes negative at one point. The slope is always positive in that graph. If the slope never changes sign, right, and the slope always either stays as a positive, or it could also do something like that as a negative, you will only cross the x-axis one time. Right? The slope has to at least level off, all right, if it's going to cross the x-axis more than once. And in fact, it has to, if it's going to cross 3 times, it has to change direction and then come back. All right, so let's calculate the 0 for that. Where's my question? There's my question. X cubed plus 2x minus 1 equals 0. So second calculate, 0. And you can't just hit enter 3 times. If you just do that, it's not going to work. Okay, you do have to be a little bit careful about where you put your cursor. So pick a point to the left, to the right. The guess, as long as you've done the left and the right, the guess doesn't matter. Okay, so let's go 3 decimal places, 0.453. That is the 0, that is the root. It's the x value in the coordinate for where it crosses the x-axis. So that is not something I would show you how to do on the test. So if it says to find the 0, and you're like, I don't remember the button to press, that's something I'm testing you on to see if you remember. Okay. All right. Any question how I got that? All right, so let's talk a little bit about just cubics in general to finish up. So a cubic polynomial has that format. It can have 4 different terms: a cubic, a quadratic, a linear, and a constant. Doesn't have to have them all. It does have to have a cubic term, where it's not a cubic. The simplest cubic is just f of x equals x cubed. That's what we call the parent function. In that case, b is 0, c is 0, d is 0. They're all 0. And a is 1. Okay. So page 80 shows different kind of cubics, but I'm showing you some right here. So cubics can have that behavior where they they try to make a turn, but they never do. Or they can have the behavior where they actually make that turn, slope changes direction, and then slope changes direction again. But they cannot turn more than twice. Okay? So they can cross the x-axis up to 3 times. And that would mean turning up to 2 times. Okay? Can only turn 2 times at most. Okay, does everybody have what they need for those different kind of cubic polynomials? Now, I think I mentioned it earlier, but every polynomial that you draw, not just cubics, quadratics, quartics, anything, they are connected. Meaning you can start somewhere and you stop somewhere, and you never lift your pencil the whole time. Okay? All polynomials are what we call continuous. You never lift your pencil when you're drawing it. There are other graphs we study that are discontinuous. Right? And we'll get into some of those in later chapters. Okay, let's look at this one. Okay, question is, how many solutions does the following equation have? First, we're setting it equal to 0. Could you tell me the maximum number of solutions it could have? Yeah? 3. What about the minimum? Yeah?
1.
Has to have 1. Okay? These type of polynomials, which this is called an odd degree polynomial, has to cross the x-axis once. Has to. Even degree polynomials, like parabolas, do not. Okay. All right, so could have up to 3, maybe only has as little as 1 to figure out the exact number. Let's draw it. So we've got x cubed minus 5x squared plus 6x minus 1. I think I'm already on Zoom 6, but I'll do it again. Okay, I think now we have the answer to that question. How many solutions does that equation have? Yeah,
3.
it does have 3. Now, technically, it always has 3. It's just that sometimes the other answers are imaginary. Okay, so for now, when I ask you how many solutions does it have, and we say, well, it could have as few as 1, I mean 1 real. Okay? If it had 1 real, the other 2, which are there, are imaginary. Okay? But we're focusing on real numbers right now. Okay, so it has 3. Bless you. And now it says to find the middle root. The middle just means visually find the one that's in the middle. So they want the root that's right there. All right, so let's see if we can do that. Marcelo, can you remind me how I get that root again?
Second trace.
Yep.
And then
2. Perfect. And then you pick your point to the left. Go to the right, do your guess. And if you've done that right, that's a root at 1.55. As far as rounding, I would generally say we do a lot of rounding to either 2 or 3 decimal places. I will always make sure I clarify on the test how many decimals. Okay, for homework, you could do 2. That's fine. Any questions on that? Now, the other thing is, if I asked you for the other roots, you can't assume that these other two roots here and here, like that one is exactly in the middle. It might not really be in the middle if I kind of exaggerate it, like that. Now you can tell that is not in the middle of the other two exactly. All right. So I just mean the one, when I said middle, I meant it's between. I don't exactly mean it's dead center of the other ones. Okay. All right. Any other questions on 2.1? Okay. So tomorrow we're going to look at 2.2. So for tonight, the homework is on page 82. And that says 1 through 5, 8 through 11, and then some single problems. 15, 27, 28, 31, 34, 40, and 45. Okay, so we'll go over that first thing, and then we'll pick up with our next lesson, which is 2.2.